Okay, Assalamualaikum and good day everyone. So today we are going to continue with lecture 3 of 5 for chapter 6. So we are going to focus on the second subtopic, which is remainder theorem, factor theorem and zeros of polynomial. For today's lecture, we are going to focus on the factor theorem and zeros of polynomial. At the end of the lesson, students should be able to, the first one is to apply the factor theorem to solve problem. And the second one is to find the roots of equations and the zeros of a polynomial. What is factor theorem? If the remainder obtained from dividing the polynomial by x minus a is 0, then x minus a is a factor of px of the polynomial. Okay, now if we relate back with the remainder theorem, so we will have remainder the same as we substitute the value of a into the polynomial. Now if we substitute the value of a into the polynomial and we get 0, means that we have remainder equal to 0, means that we don't have any remainder. So, the x minus a is a factor of polynomial. If p of a equal to 0, so the remainder equal to 0, then x minus a is a factor of px. Note that conversely, if x minus a is a factor of px, then pa is equal to 0. Means that if we know that x minus a is a factor of px, then we can use PA equal to 0 to solve the problem. In general, if AX plus B is a factor of PX, then a polynomial of negative B over A equal to 0. Okay, so AX plus B is a factor, means that the remainder of AX plus B equal to 0, x equal to negative b over a. So we replace the value x with negative b over a. So we get p of negative b over a equal to 0. So let's do with the example. Show whether the following linear expressions are factor of a given polynomial. So we have polynomial in a equal to 3 minus 7x plus 5x squared minus x cubed. So we want to check whether x minus 3 is a factor. So what you need to do is to check whether p of a equal to 0 or not. So what is the a for question A? So x minus a equal to 0 means that the value of a that we need to substitute into the polynomial is 3. Yes. So we substitute 3 into the polynomial. So p of 3 equal to 3 minus 7 multiplied by 3 plus 5 of 3 squared minus 3 cubed. So we have 0, means that we can say that x minus 3 is a factor of px. So we do the same step for question B. So we have a factor of 2x. So what is the value of a that we need to substitute into the polynomial? A equal to 0. So p0 is equal to 2 of 0 plus 3 of 0 square minus 8 of 0 plus 3, which is equal to 3. So it's not equal to 0, then 2x is not a factor of px. So example 2. If 2x plus 1 is a factor of polynomial. So now we know the fact that 2x plus 1 is a factor. Means that what we can say? So p of negative 1 over 2 equal to 0. So this is a known fact. So we can relate the theorem. So p of x equal to 2x cubed plus px squared minus 5. We can find the value of p by using this theorem. So what we need to do, just substitute x with negative 1 over 2 and then equate to 0 because it's a factor, so we don't have any remainder or remainder equal to 0. So what we have here, negative 1 over 2. Substitute the value -1/2 into the polynomial. We have 2 of -1/2 cube plus p of -1/2 square minus 5 equal to 0. So find the value, let the b will be the subject. So what do we have? 1/4 p equal to 21/4. So p equal to 21. Okay. Next example. Example 3. Given that x minus 2 and x plus 1 are factors of the polynomial px equal to 2x cubed plus ax squared plus bx minus 5. Find the value of a and b. So, previous question, example 2, we only have one factor given and we want to find one unknown. But here, we need two factors because we want to solve for two unknowns. Right? So, we do the same thing as question number 2. Means that we know that x minus 2 and x plus 1 are the factor. So, p of 2 equal to 0. P of -1 also equal to 0. So, we will have two equations with two unknowns and then we can solve by using the simultaneous equation. So, what is p of 2? So, p of 2, substitute 2 into the polynomial. We have 2 of 2 cubed plus a of 2 squared plus 2b2 minus 5 equal to 0. And simplify it, we have 4a plus 2b equal to -11. This is the first equation. Now, for the next equation, we substitute -1 into the polynomial. So we have 2 of -1 cubed plus a of -1 square plus b of -1 minus 5 equal to 0. So we have a minus b equal to 7. This is the second equation. Now we can solve by using simultaneous, either by using elimination method or substitution method. Penghapusan ataupun penggantian. So here it will be easier if we multiply the second equation by 2 to have 2b, or you can rearrange the a here equal to 7 plus b. Okay, I think here it's better to use the substitution, but for this example they want to use the elimination. So they multiply the second equation by 2, we get 2a minus 2b equal to 14. And then because we have 2b on the first equation, second equation also we have -2b. So we can just add up the two equation. Equation 1 and equation 3 add up. 4a plus 2a is 6a. 2b plus -2b is 0. So 6a equal to -11 plus 14 equal to 3. So a equal to 1/2. Now we can find what is the value of b. B equal to a minus 7. So 1/2 minus 7 equal to -13/2. So we have the value a and b just by using the factor theorem. Now, example 4. Given the polynomial px equal to 3x cubed plus ax squared plus bx minus 12 is divisible by x squared plus 2x minus 3. Compute the values of a and b. Factorize Px completely. So question A, I think everyone can do. How? What it means by divisible? So if it's mean divisible, we don't have remainder. Okay? We don't have remainder means that if we divide with x squared plus 2x minus 3, the remainder will be 0. Okay, Rx equal to 0. So, for x squared plus 2x minus 3, it can be written as x minus 1, x plus 3, means that x minus 1 and x plus 3 is a factors or are factors of Px. If we find polynomial of 1, it will be 0. Polynomial of -3 also will be 0 because it's divisible by this x minus 1 and x plus 3. So both are factors. So we can use this fact to solve the unknown A and B. Right? So P of 1 equal to 0, P of negative 3 equal to 0. So substitute 1 into the polynomial. We have 3 1 cubed plus A of 1 square plus B of 1 minus 12 equal to 0. So A plus B equal to 9. This is the first equation. And substitute negative 3 into the polynomial. So we have 3 of negative 3 cubed plus A of negative 3 square plus B of negative 3 minus 12 equal to 0. So we have 9A minus 3B equal to 93. So simplify, we get 3A minus B equal to 31. This is the second equation. So how to solve for this by using simultaneous method? So we can see we have plus B here and minus B. So we can just add up the two equations. Equation 1 plus equation 2. A plus 3A is 4A. B plus negative B is 0. 9 plus 31 is 40. So A equal to 10. So B equal to 3A minus, 10 plus B equal to 9. Okay, substitute the value of A into the first equation. So B equal to negative 1. So now we have the value of A and B for the first question A. How about the second equation? Factorize Px completely. So therefore Px equal to 3x cubed plus 10x squared minus x minus 12. So because we have the A and B already, right? Okay, now for question B. Okay, they ask you to factorize Px completely. We know Px equal to 3x cubed plus 10x squared minus x minus 12 after we find the value of A and B. And we also know that dx divisible by x squared plus 2x minus 3. The polynomial is divisible by this. Means that we don't have remainder. To factorize it completely, we can use the long division. Okay, so we apply long division. So we will have the quotient to factorize the Px completely. So because it's power of 3 means that we will have 3 times of linear, or 1 linear, 1 quadratic, right? Because we have the quadratic already, so we have 2 factor already. We need to find another factor here. That's why we use long division to find the other factor. So by using the long division, what do we have here? So for x squared to get 3x cubed, we have to multiply by 3x. So everything on the bottom, we have 3x cubed plus 6x minus 9x. So subtract this value. What do we have? So as usual, I like you to put bracket here lah. So 3x cubed minus 3x cubed is 0. 10x squared minus 6x squared is 4x squared. Negative x minus negative 9x is negative x plus 9x is 8x. So 4x squared plus 8x. And bring down the negative 12. So now from x squared to get 4x squared, we have to multiply by positive 4. So plus 4 up there. So we get 4x squared plus 8x minus 12. So what is the remainder? It will be 0 because it's a factor. We don't have remainder. Okay. So now what do we have here? This Px can be written in the form of, remember, Px is equivalent to dx cube x plus rx. So because the rx is equal to 0, so we only have dx and qx. So what is our dx? It's x squared plus 2x minus 3. And what is our qx? It's the top one, 3x plus 4. So the remainder is 0. So we can factorize the x squared plus 2x minus 3 as x minus 1x plus 3. And the other factor will be 3x plus 4. This is in the form of factorized completely. Okay. Okay, sometimes we have a quadratic factor that we cannot factorize. So we should leave it as a quadratic lah. We should stop here. If this quadratic cannot be factorized. For example, if we have a value of the the factor will be in the form of plus cert or plus minus cert, right? Square root. So we cannot factorize completely like this. So we just leave it as x squared something something something. But if we can factorize it into the factor form, then you can write down the answer like the final one here. So we will have 3 factor for cubic polynomial. Okay, so if we have 2 power of 4 quartic, then we should have 4 factors, 4 linear factors. It can be 4 linear factors. Okay, so that's for question B. Okay, roots and zeros of a polynomial. What is the definition of these two terms? So, a zero of a polynomial is a number a such that p of a equal to 0. So, what we find out earlier, we know that the factor x minus a is a factor when the remainder equal to 0, right? So, this value of a here is, we call it as 0. So p of a is equal to 0, means that the a is the 0 of the polynomial. Why? Because when we substitute the value of a, we get 0. That's why the name is 0. X equal to a is called a root of polynomial equation px equal to a. Okay, so we know that a is 0, then x equal to a written as x equal to a is root. So root is written as x minus equal to a. But 0, we can write down the zeros of the polynomial equal to a, b, c. Just the value itself. But for root, we have to write down x equal to a, x equal to b, x equal to c. A constant lah. Okay, so this root, actually we've learned it in high school, quadratic, when we find out the punca. Root is punca. So what is, apa dia punca untuk quadratic, persamaan quadratic ini? So punca is root. Okay, we write down as x equal to a, x equal to something something, right? So that is root. Just the new thing here is 0. How to write down 0? We just have to write down the value itself without the x. Don't be confused. In general, if x equal to a is a root of polynomial equation px equal to 0, then x minus a is a factor. Why? Because the remainder is 0, right? And then a is the 0. Okay? Example. So we have px equal to x cubed minus 2x minus 5x plus 6. Then we factorize it. We have x minus a, x plus 2x minus 3. So the zeros here is 1, negative 2, and 3. And then the roots here is, factorize out this one, we have x equal to 1, x equal to negative 2, and x equal to 3. So notice the difference between zeros and the way to find the roots. For root, we have to write down px equal to 0. For px, we just have to factorize the polynomial. Okay? Okay, now for question number 5. Example 5. Given px equal to 2x cubed plus x squared minus 8x minus 4. Show that negative 2 is 0 of px. What is 0? When we substitute the value into the polynomial, we get 0. So, write down, substitute negative 2 into the polynomial. We have 2 of negative 2 cubed plus negative 2 squared minus 8 of negative 2 minus 4, which is equal to 0. So, shown. Okay? Okay, since p of negative 2 equal to 0, then negative 2 is a 0 for px. Now, for question B, we need to factorize completely. So, we know already negative 2 is 0. Means that what is the factor? We can write down x plus 2 as the factor of the polynomial. Okay, so to find the other factor, we can use long division. Okay, so long division here, we get, to get 2x cubed for x, we have to multiply with 2x squared. So we have 2x squared plus 4x squared, 2x cubed plus 4x squared. So subtract this. So we have 0, and then this one is negative 3x squared. So bring down negative 8x minus 4. So we have multiply with negative 3x. So we have negative 3x and negative 6x. Negative 3x squared minus 6x. So subtract this term. So we have 0 here and negative 2x. So bring down negative 4. So we need to multiply x with negative 2. So negative 2x minus 4 equal to 0 remainder. It should be 0 lah. It cannot be other numbers. It should be 0 because it's a factor. So Px can be written as x plus 2 multiplied by 2x squared minus 3x minus 2. So this is the quotient. This is the divisor, and we have remainder 0. Right? So we don't have to write the plus 0 lah. Okay, so now the 2x squared minus 3x minus 2, can we factorize it? You can just directly use your calculator. If we get in the form of fraction or integer, so we can directly put into the two factors. So if you use calculator, we get 2x plus 1, x minus 2, or you get x equal to negative 1 over 2 and x equal to 2. So write down in the factor form, it will be 2x plus 1 equal to 0 and x minus 2 equal to 0. So these two will be the factor. That's why the answer is 2x plus 1 multiplied by x minus 2 multiplied by x plus 2. Okay, so this is the factorized completely form. Everything in the lowest degree, which is to x to the power of 1. Now, hence write the zeros. Okay, hence, so means that we use the previous answer, which is the factorized completely. We know that Px can be factorized into a form of 2x plus 1, x minus 2, and x plus 2. What are the zeros for this polynomial? Directly, it will be equal to, this is zeros, zeros. The other zeros is, this one we know already from the question, right? So the other zero should be 2x plus 1 equal to 0. So x equal to negative 1 over 2 and x minus 2 equal to 0. So x equal to 2. So the zeros is negative 1 over 2 and 2. So this is the answer. The other zeros. Write the other zeros. The non-zeros from the question tak payah tulis lah. Okay, so we have another 2 zeros here. Negative 1 over 2 and 2. Example 6. Show that 3x minus 2 is a factor of 6x cubed minus 7x squared minus x plus 2. Hence, find roots of the equations of the polynomial 6x cubed minus 7x minus x plus 2 equal to 0. So how to show that this is a factor of this one? So this is our polynomial lah. 6x cubed minus 7x squared minus x plus 2. So how to show that 3x minus 2 is a factor? You can substitute the value of, this is x equal to 2 over 3. So P of 2 over 3, what is the value? The value should be equal to 0. So show that 6x of 2 over 3 cubed minus 7 of 2 over 3 square minus 2 over 3 plus 2. So use your calculator, you get 0. So x plus 1 is one of the factor, not x plus 1. This is some typo here. It should be 3x minus 2 is one of the factor of Px. Okay, because we show that P of 2 over 3 equal to 0. The remainder equal to 0. Remember from the remainder theorem, P of A is the same as R of A. If P of A 0 means that remainder also 0. Okay. To get other factors, because the next question is hence find roots of the equation. So means that we have to factorize this Px factorize completely. Okay, to factorize completely, we use the long division. So, to get 6x cubed from 3x, we have to multiply by 2x squared. So, 2x squared minus 4x squared. So, we have the remainder of negative 3x squared. Bring down a negative x. So, negative multiply by negative x, because we have 3 already here. So, we just have to multiply by negative and x. Okay. So, negative 3x squared plus 2x. So, subtract this value. This one will be 0. This one will be negative 3x. Bring down plus 2. So, it should be multiplied by negative 1. Negative 1 of 3x is negative 3x. Negative 1, negative 2 is plus 2. Right? So, it will be remainder 0. So, what do we have here? The 6x cubed minus 7x squared minus x plus 2 can be written as the dx multiplied by qx plus 0. So, dx multiplied by qx only. So, 3x squared, 3x minus 2 multiplied by 2x squared minus x minus 1. Can we factorize 2x squared minus x minus 1? Use your calculator. We have x equal to negative 1 over 2 and x equal to 1. So, that's why it will be 2x plus 1 and x minus 1. So, this is the answer for find the other factor. So, the roots, sorry, not other factor but roots. So, what are the roots of this? Just take out the value of x here. So, we have 2 over 3, negative 1 over 2, and 1. Okay? Please answer the question accordingly. If they ask for roots, give the roots, not just leave it as a factorize of the polynomial. Okay, example 7. Given a polynomial x equal to 2x cubed plus 3x squared minus cx plus d, where c and d are constants, one of its zeros is 1. When px is divided by x minus 2, the remainder is 12 minus 3x. Find the values of c and d. Okay, now we don't have all factors or all zeros. Okay, but we have 1 zeros here, which is equal to 1, means that the x minus 1 is factor. And p1 means that p1 equal to 0. So, we will have one equation here, but we want to find two unknowns c and d. So, the other information we have is px is divided by x minus 2. The remainder is 12 minus 3x. Means that p of 2 will have 12 minus 3x as the remainder. So, 12 minus 3x means that the x also equal to 2 lah. Because rx equal to 12 minus 3x. So, r of 2 will be 12 minus 3 of 2. So, now we have two equations, right? Because this is equal to 2 lah, x equal to 2. So, what you have to do is to find the two equations and solve it simultaneously. So, the first one is zeros is 1. So, p of 1 equal to 0. So, substitute 1 into the polynomial. We have 2 of 1 cubed. And p of 2 we get 12 minus 3x. So, we have two equations lah. The first equation, substitute 1 into the polynomial. 2 of 1 cubed plus 3 of 1 squared minus c of 1 plus d equal to 0. So, simplify it. We will have d minus c or negative c plus d equal to negative 5. So, this is the first equation. The second equation, substitute 2 into the polynomial and 12 minus 3 of 2. So, we have 2 of 2 cubed plus 3 of 2 squared minus c of 2 plus d equal to 12 minus 3 of 2. So, now we have negative 2c plus d equal to negative 22. This is the second equation. So, to solve it, we can use the simultaneous equation by using either elimination method or substitution method. Here is better to use the elimination method because we have d and d. D here and d here. So, we just have to subtract between these two d. So, equation 1 minus equation 2. So, we have negative c minus of 2c is equal to c, and then d minus d is 0, And negative 5 minus negative 22 equal to 70. So directly we have C equal to 17. Now substitute C equal to 17 into the equation 1. We have negative 70 plus D equal to negative 5. So D equal to 12. So we find out the value of C and D. So this is for the first part of the question. Find the values of C and D. So this one is not our answer. Just we want to write down back the Px in the value C and D. So we have Px equal to 2x cubed plus 3x squared minus 70x plus 12. Now for question B. So factorize Px completely. We know already that 1 is zeros, means that x minus 1 is one of the factor of Px. So we can use long division to find the other factors. So what is the other factor? So we use long division. We get, to get 2x cubed, we have to multiply x with 2x squared. So 2x squared multiplied by x, 2x squared minus multiplied by negative 1, we have 2x cubed minus 2x squared. So what is the remainder? We will have 5x squared. So bring down negative 17x. And then to get 5x squared, we have to multiply the x with positive 5x. So positive 5x multiplied by x is 5x squared. 5x multiplied by negative 1 is negative 5x. So what is the remainder? So we have negative 12x. And then bring down the plus 12. So to get negative 12x, we have to multiply x with negative 12. So negative 12x minus negative 12 multiplied with negative 1 will be positive 12. So we will have remainder 0. It should be 0 because it's a factor. So now Px is equal to the divisor multiplied with the quotient, or quotient multiplied with divisor, either one. Both are correct. Now we have 2x squared plus 5x minus 12. So can we factorize this quadratic into linear factors? So use your calculator. So we can write down, because we have x equal to 3 over 2 and x equal to negative 4. So it will be 2x minus 3 equal to 0, x plus 4 equal to 0. So these two will be the factor. Okay, so 2x minus 3, x plus 4, x minus 1. This is in the form of factorized completely, because all in the linear factor. Okay, we good? Yes, so this is how you solve for the question B, to factorize completely by using the long division. So that's all for lecture 3. I hope you guys understand. If not, you can ask me anytime in the Telegram, or you can just PM me in Telegram or WhatsApp. Okay, and please try to continue with the tutorial question number I think 7 and 8. Okay, so that's all for this lecture. See you guys on the next lecture on Wednesday. So thank you.